Welcome to Fun Facts Daily, your source for just the good stuff. Monday through Friday, we're bringing fun facts and news you can use, all carefully curated to uplift and inform. So give yourself a break, relax, and learn something awesome in just a few minutes every day. Hi everyone, I'm Kyle Wood, and today we're going to be learning about some scientists who deserved a little more recognition. But before we get into the facts, let's warm up our brains with a little challenge to see if you can tell fact from fiction. Consider this. In 1967, astronomers discovered pulsars, which are rotating neutron stars that emit beams of electromagnetic radiation. The Nobel Prize for this discovery went to a professor, but some say the award should have gone to someone else. Rumor has it the initial detection and data analysis were actually completed by a graduate student. What do you think? Did a student find a significant astronomical phenomenon while her professor got the highest scientific award for it? We'll find out at the end of the episode. Now for your word of the day. Our word for today is anomaly. That's A-N-O-M-A-L-Y. An anomaly is a deviation from the common rule, type, arrangement, or form. In scientific research, an anomaly refers to a data point or observation that doesn't fit an established pattern or theoretical model. Researchers depend on anomalies to identify new phenomena, as unexpected results often point to undiscovered principles. When an experiment yields an anomaly, scientists investigate whether the result stems from an equipment error or a genuine breakthrough in human understanding. The word anomaly comes from the ancient Greek word anomalia, which translates to inequality or unevenness. Originally, astronomers used the word to describe an uneven motion of a planet in its orbit. Over time, the definition expanded to any irregular measurement or occurrence. Many overlooked scientists, including ones we're discussing today, made their lasting contributions by refusing to ignore data anomalies. They pursued the uneven results until they established new baseline facts for their respective fields. Time for your daily high five, our top 5 fun facts about scientists who deserve some more recognition. Number 1. A botanist named Anna Atkins created the first book illustrated by photographic images by mastering the cyanotype process in 1843. Anna Atkins was an English botanist who collected and studied algae and ferns. She learned the cyanotype process, a photographic printing method that produces a cyan blue print. She was actually taught the process by its inventor, Sir John Herschel. Atkins placed her botanical specimens directly onto paper coated with light-sensitive chemicals and exposed them to sunlight. The resulting images, called photograms, captured the outlines and structural details of the plants without the need for manual illustration. This technique provided a level of accuracy that traditional scientific drawings just couldn't achieve. In 1843, Atkins self-published Photographs of British Algae, Cyanotype Impressions. It was the first book in history to use photographic illustrations. Despite this milestone, art and science historians frequently credited William Henry Fox Talbot with producing the first photographic book, as his work gained wider commercial distribution. Modern institutions now recognize Atkins as a pioneer in scientific illustration, and her original cyanotypes are preserved in museum collections as foundational works of photographic art. Number 2. A 23-year-old chemist named Alice Bell developed the first effective treatment for leprosy. Alice Bell was a chemist who worked at the College of Hawaii in the early 20th century. She developed a technique to extract the active ingredients from chalmugra oil. Prior to her work, the oil was used to treat leprosy, but it was difficult to apply and absorb. Ball created a water-soluble, injectable form of the oil that the human body could actually process. This provided the first effective treatment for a disease that had afflicted populations for centuries. Tragically, Ball died at the age of 24 in 1916. While the official cause was listed as tuberculosis, many historians believe she accidentally inhaled chlorine gas in a lab without proper ventilation. She passed away before she could publish her findings, but the president of her university, Arthur Dean, continued her work and published the findings, but just under his own name. He didn't mention Ball or give credit to her original chemical process. Decades later, researchers uncovered her original lab records and restored her name to the process. Today, the University of Hawaii honors her contribution with a plaque near the Chalmugra tree on campus. Number 3. Henrietta Swan Leavitt discovered the mathematical relationship that allows astronomers to measure the distance of faraway galaxies. Henrietta Swan Leavitt worked at the Harvard College Observatory in the late 19th and early 20th centuries. She analyzed photographic plates to measure and catalog the brightness of stars. During her analysis, she focused on Cepheid variables, which are stars that pulse in brightness at regular intervals. Leavitt recorded a direct mathematical relationship between the period of a star's pulsation and its intrinsic luminosity. This discovery provided astronomers with a means to calculate distances across space. The astronomer Edwin Hubble used Leavitt's mathematical baseline to calculate the distance to the Andromeda Galaxy. His calculations proved that the universe has galaxies beyond the Milky Way and that the universe was expanding. Unfortunately, Leavitt received little recognition during her lifetime. But 4 years after she passed away, a colleague tried to nominate her for a Nobel Prize, and today the scientific community refers to her discovery as Leavitt's Law in honor of her foundational work. Number 4. Eunice Newton Foote first discovered the greenhouse effect all the way back in 1856. Eunice Newton Foote was a scientist and inventor who conducted experiments on atmospheric gases back in the 19th century. She filled glass cylinders with different mixtures of gases and placed them in direct sunlight. Foote inserted thermometers into the cylinders to monitor temperature changes. She found that the cylinder containing carbon dioxide reached a higher temperature and retained heat longer than the cylinder containing normal air. Based on this observation, she concluded that an atmosphere composed of carbon dioxide would increase the temperature on the Earth. Foote submitted her findings to the American Association for the Advancement of Science. A male colleague had to present her paper because women were not permitted to speak at the conference. 3 years later, a physicist named John Tyndall published similar findings and received historical credit for discovering the greenhouse effect. Foote's original paper remained hidden in scientific archives for over a century until researchers located it, and it was finally published in 2011. Climate scientists now recognize her as the first person to demonstrate the heat-trapping properties of carbon dioxide. And our fifth and final fun fact for today, the mathematician Gladys West programmed the complex computing models that made global positioning systems possible. Gladys West worked as a mathematician at the Naval Surface Warfare Center starting in 1956. She specialized in analyzing data collected by satellites to map the exact shape of the Earth. The Earth is not a perfect sphere. It's an oblate spheroid. It has all sorts of irregularities, ocean trenches and mountain ranges that alter its gravitational pull. West programmed an IBM 7030 stretch computer to process complex algorithms that accounted for these gravitational variations and tidal forces. Her calculations resulted in an extremely accurate mathematical model of the Earth known as a geoid. This geoid model became the foundation for the Global Positioning System, or GPS, which relies on exact Earth measurements to coordinate satellite signals. For decades, West's contributions were classified military information, and the public credited the engineers who built the physical satellites. Her role only became public knowledge when she submitted a short biography for a sorority event in 2017, and she detailed her work on the satellite project. In 2018, the United States Air Force inducted West into the Space and Missiles Pioneers Hall of Fame, acknowledging her programming as the bedrock of modern navigation. Now for some news you can use. If you want to uncover overlooked facts in history or science, try reading primary sources instead of just relying on secondary summaries. A primary source is an original document from the time of an event, like a laboratory notebook, a direct photograph, or an original research paper. Secondary sources, like textbooks or encyclopedia articles, summarize the primary data but often streamline the narrative, which is how many collaborating scientists have gotten edited out of history. You can access millions of digitized primary sources through platforms like the Library of Congress, the National Archives, and universities' digital collections. When you read the original letters and lab notes surrounding a scientific discovery, you see the messy, collaborative process of science firsthand. Primary source analysis builds critical thinking skills and helps you spot the difference between an established historical narrative and the raw empirical facts of what actually happened. And finally, the moment you've been waiting for. At the beginning of the episode, I asked if a graduate student actually discovered pulsars only to watch her supervisor receive the Nobel Prize. That's a fact. In 1967, Jocelyn Bell Burnell spent months analyzing miles of printouts from a radio telescope she helped construct. She noticed a precise repeating anomaly in the data, a radio pulse occurring every 1.33 seconds. Her supervisor, Anthony Hewish, initially dismissed the data as artificial interference. He actually jokingly called it LGM-1 for Little Green Men. But Burnell persisted and proved the signal was originating from a rapidly spinning neutron star, later named a pulsar. In 1974, the Nobel Committee awarded the prize in physics for the discovery of pulsars to Anthony Hewish and the astronomer Martin Ryle. The committee excluded Bell Burnell, sparking a major controversy in the scientific community about the treatment of student researchers. For her part, Burnell handled the snub with professionalism, saying that Nobel Prizes should go to project directors to maintain the prestige of the award. Decades later, she received a special breakthrough prize in fundamental physics and donated the $3 million award to fund scholarships for underrepresented groups in physics. Now, I hope you enjoyed learning a bit about these underappreciated scientists with me today, and be sure to tune in every weekday for even more fun facts. Fun Facts Daily is an Airwave Media podcast. It was written, recorded, mixed, and edited by me, Kyle Wood. Thanks for sharing a part of your day with me. Be sure to follow Fun Facts Daily on your favorite podcast app so you can keep the good stuff coming your way every day. And if you like the show, please do me a favor and leave a kind rating, review, or just tell your friends about it.